Today I'm going to be talking about the Pythagorean theorem, how it is used in the real world, how to use it, and why it works. So without further ado, let's get into it. One of the great mysteries in the math world is who made the Pythagorean theorem. Unfortunately, no one really knows. Perhaps the proof of the theorem was first offered by the mathematician known as Pythagoras. But what we do know is that it was discovered and used long before his time. So what are some ways that the theorem is used today? It can be used to find the size of a television. It can also be used to figure out how long a ladder needs to be to reach a certain height on a wall. It is also used frequently by engineers, architects, and construction and building inspectors. So what exactly is the Pythagorean theorem? Well, it says a squared plus b squared equals c squared. Or you can say leg 1 squared plus leg 2 squared equals hypotenuse squared. How do you use it? First, it can only be used with right triangles. Second, substitute the values for leg 1 and leg 2 into the equation to calculate the value for hypotenuse squared. Then, take the square root of both sides of the equation to find the value of the hypotenuse. For example, let's say a equals 3 and b equals 4. What is the value of the hypotenuse, c? Write the actual equation down first. A squared plus b squared equals c squared. Then substitute the values for a and b. 3 squared plus 4 squared equals c squared. 3 squared equals 9, and 4 squared equals 16. 9 plus 16 equals 25. So now we have 25 equals c squared. Now take the square root of both sides of the equation, and we have 5 equals c. Why does all of this work? Well, let's try this. Take a right triangle and form squares that have side lengths equal to the length of each side of the triangle. Using the equation for area of a square, find the area of each square. The area of the blue square is leg 1 squared. The area of the green square is leg 2 squared. The area of the red square is hypotenuse squared. When you add the area of the blue and green square, you will find that it is equal to the area of the red square. Let's go back to our example where leg 1 equals 3, leg 2 equals 4, and the hypotenuse equals 5. The area of the blue square is 9, the area of the green square is 16, and the area of the red square is 25. The area of the blue square plus the area of the green square equals the area of the red square. As you can see, the area of the squares along each leg of the triangle is equal to the area of the square formed on the hypotenuse. And there we have it. A squared plus b squared equals c squared is the Pythagorean theorem.